today's class, we're going to be discussing the introduction to motion. For those of you who are using the packet as a reference, these are on pages 27 and 28. And if you happen to see some purple slides, it just means that there's new information that is being added to those pages. The reason for that is because this year we are moving at a much different pace than we normally do. So you just may have to add those pieces of information in because it's not on the paper. So when it comes to measurements, we had qualitative and quantitative, and then we also have scalar and vector quantities. Now, quantity uses numbers to describe measurements. Remember, the way I teach it as is when you see the letter N, that stands for numbers. So when you see numerical values, you have a quantity measurement. When you have quantity measurement, you can have either a scalar or a vector quantity. Scalar is when you have a magnitude only. Magnitude is a fancy word of just saying numerical value. So when you see a numerical value in a unit, that's simply a scalar quantity. For example, 5 meters, 10 kilograms, 24 meters per second. When you have a vector quantity is when you have both a magnitude and a direction. Again, magnitude is just the numerical value, and now you have direction added to it as well. So now we see 5 meters west, 10 newtons to the right, 24 meters per second north. So now you have both the numerical value as well as the unit and the direction, which makes it a vector quantity. Note the difference between the two. There's going to be many times where you have to identify between each, and you would also have to indicate direction at the appropriate time. All right, with the introduction to motion, we're going to have different terminology that we're going to use. As far as position is concerned, it's the separation between an object and a reference point, as in how far is an object from the origin. With the distance, it doesn't need a reference point. Now in the second portion, I've highlighted it, but also this is different than what's on your packet. So make sure that you add this in. Distance is essentially how far an object has traveled in total. Think of the odometer of a car. It simply keeps on adding and tracking on the miles. It doesn't care which way you went. It just keeps adding and adding and adding. Doesn't matter how many times you went to work and came back home. It doesn't reduce it. It just keeps on adding the mileage. So for distance, it is how far an object has traveled in total. Next thing that you may have heard or may have not heard is displacement. Displacement is a change in position, or delta D, of an object, and it is a straight line distance between two objects and the direction from one another. Oftentimes, students get distance and displacement confused, so let's hope that we can go ahead and have some examples that prevents you from confusing the two. With displacement, you're looking at the change in position of an object. Again, that's the distance and direction because displacement is a vector quantity. So once you have direction involved, it becomes a vector quantity. And the change is typically noted by delta D. And also in this class, right and up is usually positive for us, and left and down is negative. Think of it as the x and y axis of a graph. Anything to the right, anything upwards is always positive. Anything to the left, anything downwards is negative. So in physics, there's times where we use the symbols to indicate direction. For example, if you see a negative 10 meters per second, there's no possible way for anyone to go negative speed. So now it's a direction. Your speed is 10 meters per second, but the negative indicates the direction, which is either to the left or downwards, and now you refer to that as velocity. Remember that speed is just simply a numerical number, and velocity is the numerical number with the direction. Okay, so now let's look at a difference between distance and displacement. Distance would be considered what you actually did on a Saturday night. You may have drove to your friend Kensley's house, then drove to Gigi's house, went to Target, went to Starbucks, went to the movies, dropped off Gigi, went back to Kensley's house, and then finally went back home. During this whole time, your mileage keeps adding on. Every time you make a trip, the mileage keeps adding on and adding on. The displacement, though, would be similar to what you tell your mom you did on Saturday nights, which is you could say you went to Kensley's house, worked in physics homework, and came home. Your displacement at the end of that night is 0 miles because you started from home and you came back home. So there was no change in displacement. However, you are not getting your mileage back and you are not getting your gas back either. That was taken off with the distance. Remember, your odometer doesn't care where you went, doesn't care how many times you come back home. It is not refunding you your gas or your mileage. It just keeps adding on and adding on. So, is distance and displacement always going to be the same number? The answer to that is no. Let's look at another example. A hiker travels 8 miles east, then 2 miles north. What's the distance has he traveled, and what is his displacement? So we're going to go ahead and draw the picture. He went 8 miles east and 2 miles north, and the dotted lines represents our displacement. So in order to find a displacement, now as we see in the previous picture, you're going to use the Pythagorean theorem because it's a triangle. Or you can name either leg as A or B, doesn't matter as long as one of the legs. The hypotenuse is the longest one, and that the longest side, and that one is C. For us, that's going to be delta D because that's the displacement from the origin to where they ended up, the hiker ended up. Pythagorean theorem is going to be A squared plus B squared equals C squared. Our A leg was 8 squared plus 2 squared. So you add them up and you get 64 plus 4, which is equal to 68. Remember to always take the square root because you're after the hypotenuse and not the hypotenuse squared. So this hypotenuse here is going to be the square root of 68, which is 8.25 miles. So the hiker's total distance traveled is 10 miles, and the hiker's displacement in reference to the origin as of where he started is 8.25 miles. Now you also have to include direction, so it would be considered 8.25 miles northeast. Let's look at another example. A car moves 65 kilometers due east, then 45 kilometers due west. What distance has the car traveled? What is the car's displacement? You should always draw out the scenario first, one step at a time. And once you've drawn a complete scenario, you can go ahead and solve it. Now for distance, you don't never need a picture because you're simply always adding up. It's 65 plus 45, so the distance traveled by the car is 110 kilometers. For displacement is when you do actually need to use a proper picture. So the car traveled 65 kilometers east, that's our middle line, and then the car traveled 45 kilometers west. Now I drew this one below the middle line just for illustration purposes only, but there was no mention of him going down south. But to make the image easier to view, I just drew it down below it. Now in red, I've identified the initial starting point and the final position of the car, and those are identified by the XI and the XF. So we have an idea of where we started and where we ended. So our displacement is essentially 65 minus 45, and it gives us a difference of 20 kilometers. And again, you would have to include the direction, so it's 20 kilometers east of where they started. Moving on to another example. Ned Naylor walks 5 blocks north, then 7 blocks east, then 8 blocks south, then 3 blocks west, and finally 3 blocks north. He's very tired. What distance has he walked? What is his displacement? We're going to go ahead and draw every single direction that he walked. So first he went 5 blocks north, then he went 7 blocks east, then he went 8 blocks south, 3 blocks west, and finally 3 blocks north. Now, I will show you the full picture in a second, but remember for distance, you don't need a picture, you just simply need to add up all the numbers. It's just like the odometer in a car. Just keep adding everything. So 5 plus 7 plus 8 plus 3 plus 3. You get 26 blocks. So the total distance that he has walked is 26 blocks. Our final picture looks like this. Some of the key things is that I use a straight edge and use proportionate size for every measurement. So my 5 blocks north is not smaller than my 3 blocks. My 2 3-block sizes are the same length as each other. My 7 blocks is shorter than my 8 blocks. However, the 7 blocks is actually longer than the 5 blocks. So everything's proportionate to each other. with correct measurements. If you don't draw it properly, you could have had xf at an angle, and you may have thought that you may need to use the Pythagorean theorem. So for our displacement, it's simply 7 blocks minus the 3 blocks is equal to 4 blocks. Again, we started at xi, we ended on xf, and that's to the right of the origin. So we could say that that is 4 blocks east. For those wondering how we got 4 blocks, it is the 7 blocks on top minus the 3 blocks at the bottom. They're horizontal and parallel to each other. So based on where he ended and based on wherever he started from, it's the 7 minus the 3 blocks, and you get your answer of 4 blocks to the east. Moving on to the back page, now we discuss similarities and differences between speed and velocity. The only similarity that they have is the fact that they are both numerical values. Think about the car. You have a speedometer because it tells you the speed. You do not have a velocimeter because you don't need to know the direction that you're going. So with that said, speed is how fast something is moving, and that will always be a positive number. Remember, there's no way for you to see a negative number in the speedometer of your car. With velocity, it's the numerical speed with a direction, and the direction is either expressed as positive or negative. Positive means up or right, and negative means down or left. So again, if you're traveling, let's just use miles per hour for now. If you're going 50 miles per hour, you know which direction you're going. But in a physics problem, if you're going to go ahead and indicate that you were going west or to the left, you would say negative 50 miles per hour. Just to reiterate again, displacement and distance are not the same thing. Displacement is the ultimate change in position from beginning to end, and that is not the same thing as the total distance. Again, distance is like the odometer in the car. That is your total distance. It takes track of everything that you do, every little turn, every little mile, every bit that you drive counts against your mileage and keeps adding on. Displacement, though, is the ultimate change, meaning if you started at home, went to 10 different places, but ultimately came back home again, your displacement at that point is 0. However, that's not to say that your displacement is always 0, because as we just saw in this example, you may not end up at the same location as you started. Okay, so now we are at a purple slide, which means this is the new information being added. So somewhere on your paper, make sure that you add these info and are aware of the information. Speed is how fast something is moving, and it will always be your positive number. We have instantaneous speed, which is the speed of an object at a particular instant in time. We also have the average speed, which is your total distance traveled during a total period of time. So let's go ahead and give some examples of these. Instantaneous speed is when there is a police officer who's running a speed trap, and they just hit you with the radar or the laser to get your speed. They're looking at your speed at a particular instant of time. If you happen to be speeding at that moment, then you're going to possibly receive a speeding ticket. However, if prior to that you were going well below the speed limit, and if someone was to calculate your average speed, then you may have been going well below the speed limit. But that's the average speed, and the police officer doesn't care about your average speed as of how much your speed was during your whole amount of travel. They only care about the speed trap and the moment that it happened, essentially the instantaneous speed. So now we see in the triangle on the left, it's displaying some errors. The reason for this is because this was made in PowerPoint, and we are using Chromebooks, and sometimes they're not very compatible. So you will see this worked out in different ways. I will show you the equation that you need. Moving on to velocity. Velocity is a vector unit. Remember that velocity has a direction, whereas speed is simply a scalar unit because it's only a numerical value or with magnitude. So velocity is speed with a direction. Once again, positive means up or right, and negative means left or down. Instantaneous velocity is similar to instantaneous speed. The only difference is that now direction is included. The average velocity is now your total displacement as opposed to the total distance for average speed. So average velocity is total displacement divided by the total time. And now we see our equation. This is the first equation you're going to be dealing with in physics. Velocity is equal to distance over time. Velocity, the units for that is meters per second. Displacement, the units will be in meters, and time should always be in seconds. And if you don't have those units, then you're going to have to do conversions. And we can manipulate the velocity equation to solve for the other variables. By now, after watching the algebra review, you should be able to do this quite easily. So our equation is equation number 1, velocity equals distance over time. And we can go ahead and rearrange it for different variables. For delta D, you would have to multiply them together and you get V times T. And for time, remember the shortcut that I showed you previously, you flip-flop them and you get time is equal to delta D over V. So now let's move on to a sample problem. Susie Snails is driving along at 60 kilometers per hour while talking to her friend Ned Nugget on their cell phone. She suddenly notices a red light. If it takes her 0.75 seconds to react, how many meters will the car travel before she hits the brakes? Now, what you may have or may have not noticed is that these are all in different units. She's driving along in 60 kilometers per hour, but her reaction time is in seconds. The question is also asking us for meters, not in kilometers. So remember, in physics, you're going to be doing conversions almost all the time throughout the whole year. So our first step is to convert kilometers into meters. You can use the previous methods of King Henry died by drinking chocolate milk, or you can go ahead and multiply 60 kilometers by 1,000 because each kilometer is 1,000 meters. So our first step is to convert that over and we get 60,000 meters. Our second step is to convert hours into seconds. 60 kilometers per hour means 1 hour. And in 1 hour, you have 3,600 seconds. Remember, it's 60 minutes times 60 seconds provides us with the 3,600 seconds. Our third step is to divide 60,000 meters by 3,600 seconds in order to find her speed per second. So we have 60,000 meters divided by 3,600 seconds, and now we get 16.67 meters per second. And finally, we move on to our fourth step, which is to plug values into our equation. Our original equation, equation number 1, is velocity is equal to delta D over T. In this scenario, our velocity was 16.67 meters per second, so that has replaced V. We are solving for how far she went, so we are not doing anything to D. And her reaction time was 0.75 seconds, so that replaces T. In order to solve for delta D, you have to multiply by the 0.75 on both sides. On the right side, it crosses out. On the left side, we get 16.67 times 0.75 is equal to delta D. When you punch it into a calculator, delta D is equal to 12.5 meters. So that is our introduction to motion. Please know the difference between scalar and vector quantities. Know the difference between speed and velocity. Always be aware of your directions. If you are asked for giving a vector quantity as the answer, then go ahead and provide your direction. Okay, this takes care of today's lesson. Have a wonderful day.